Hello, everyone. We're going to get started shortly. Hello, everyone. We're going to get started shortly. Okay, all right, let's get going. Hi, everyone. Welcome to Always Coding, our weekly hacky hour. Hopefully, some of you had a chance to attend our webinar earlier this morning with NVIDIA, where we discussed how you can accelerate development for computer vision on the Jetson family of devices. So if you're joining from that, welcome to Hacky Hour. If you're new to the community, welcome to Hacky Hour. And if you've attended in the past, welcome back. Hacky Hour is just like happy hours. They're more like our office hours. So here you can bring your questions, any ideas, something you've been working on, and we're all here to just support you and guide you along the way. So today's topic is kind of an extension of our webinar from earlier, where Eric kind of walked through the model catalog, documents with alwaysAI, and then he showed how you can run a couple of apps on the Jetson family of devices, such as the Nano and the TX2 and the Xavier. So what I'm going to do is just show you how you can set up and run pose estimation locally on your laptops, and then I'll hand it over to Eric to walk through his jumping jacks app that he showed us at the NVIDIA webinar, as well as speak about some of the TensorRT models. So we're going to get started now. Let me just share my screen. Okay, so what you want to do is go on to alwaysai.co, and then you just want to log in or sign up if you haven't done so already. And today we're going to do pose estimation. So let's go ahead and create a new project once we're into our dashboard. So we're going to click new project, and we're going to click a template, which is human pose estimation, and we'll just call this HPE Hacky Hour. And then we're going to go ahead and create the project. So we're going to click to view our project. And again, if you're new to alwaysAI and you haven't downloaded the CLIs yet, you can download it directly from your dashboard by clicking download CLI for Mac OS or Windows, if that's what you're using. And as you can see, the human pose model is already added to my project, so I'm not going to make any changes to that. Unless you want to upload your own model or anything like that, I think I'm okay with just using the human pose. So with that, let's, Eric, can you see my terminal?
No, just seeing the web page right now, the dashboard.
Okay, okay, I think you should be able to see it now.
Yep.
So we're going to go into my alwaysAI directory, and then I'm going to go into the alwaysAI starter apps. And then we have all of these starter apps, and usually we do the object detector, but this time we're going to go ahead and go into the real-time pose estimator. And then just kind of double check in our app.py. So let's open up the human pose estimator app.py file and make sure that that's the pose, that's the model we want to use. So that's the alwaysAI human pose. And it looks like this is the model we want to use. So we can go ahead and run it. So we're going to do AAI app install. And then we're going to do the AI app start. And in a couple seconds, we'll see a link to a streamer, and we can just copy this and paste it into our browser window. And now I'm going to kind of head towards my skateboards to kind of show you how this works. So as you can see, this can identify all of these key points on my body, like my wrists, my elbows, my shoulders. And there's a lot of cool things you can do with that. One thing that Eric did was create a jumping jacks app, because we're all in quarantine and working from home, and we need to get some exercise in, right? So with that said, I'm going to hand it over to Eric. Hey, Eric, you ready?
Gotta unmute, or else no one can hear me. Yeah, thanks, Komal. Yeah, so today, well, if you joined earlier, you saw the demo of the Jumping Jacks app, Como mentioned. And today for the Hacky Hour, I just kind of wanted to dive into a little more like technical depth on how I built that and just go through the code then. So I'm always trying out different camera setups here. So without a whiteboard, I wanted to draw some stuff. And so I got my pad of paper. I will attempt switching to this other camera that I have, the overhead camera view, and we'll see if this works. Okay, it just says my name right now.
Yep.
Let me try a different one. Is that back to the, oh, maybe I have to, why isn't it letting me? There's a backup plan, don't worry. Okay, and now Zoom is just frozen.
No.
Give it a second to.
Okay, that's fine. While Eric is sorting out the technical issues, I have created a poll.
Ooh.
Oh,
well, go ahead.
Okay. Yeah. So I've kind of created a poll. So if you could take a look, it's just 4 questions. If you could just tell us a little bit about yourself, and then I'm going to share the results afterwards. So you can do it throughout the Hacky Hour, answer it later, whatever you want. But at the end, I will share the results. With that said, Eric, if you're ready to go, you can take over again. Yes.
Yeah, Como, real quick, can you put up the link to the NVIDIA playback of the webinar? Because that's one of the questions that's out there.
Yeah, so I think the recording of the NVIDIA webinar will be ready in a couple of days. And once that's ready, I can send it out to the entire group.
Thank you.
Thanks, Steve.
Cool. All right. So you should see this wonderful pad of paper now. Unfortunately, it's mirrored on my view. So I don't know. You guys might see my drawing backwards, but shouldn't matter. Jumping jacks are symmetrical. So kind of wanted to just go through the steps of how I went through the activity tracking here. And I think it's kind of cool because there's a lot of research out there on building computer vision apps to track a bunch of different workouts. And so this is just one specific case, but you would be able to take these techniques and use them for a bunch of different cases. So I wanted to start by just kind of going through what the data points that I was tracking looked like. So if you have like your stick figure doing jumping jacks, you would kind of see a motion with the arms, like that, and then the legs are more like out and back. And so the first step that I did to kind of simplify it is instead of working along the curves, I chose to work along only the y-axis for the arms. And that way I could just throw out the X points and make it a little simpler. Of course, you run into a little problem there if someone's doing like burpees or something like that, where your arms are going straight up and down, but I just ignored that case for now. Another thing I did to make it simpler, because I was on a short time frame, was just kind of skip out on the legs. But that would be an important part of making this app a little bit more robust. So once you start looking at the points for that you're getting with the arms, you end up getting, and if you remember when Steve was going through the coordinate systems, let's say we have our image coordinate systems, we're actually going in the positive y going down and positive x to the right. So this is our 0, 0. So what we actually see is if we had, well, that line's in the right spot, but let's pretend, let's just skip over. Sure. So if we have our y's, we end up with some, when you start with the hands down, you end up with some points that are up here, and then you'll start to see like a sinusoid like that for each hand, right? And what we want to do is, I wanted to do a simple like 0 crossing count. So the first thing I had to do is kind of shift these sine waves onto like get rid of their average. And so an easy way to do that, there's more advanced filtering techniques and stuff you could use, but I try to go with the simplest route possible. So what I did was pick the neck point because I figured that was kind of in the middle. And so I'm using that point on the neck to kind of bring these sinusoids down onto the 0 axis so I can easily count when they cross a 0. So what you end up getting then is for each arm, so left and right, we end up getting, and I also flipped it over, and I'll show that in some plots in a minute, but you end up getting something that looks like this, and then another one. And let me know if this is too small. I hope you can see it, but it's hard for me to tell.
I think it looks pretty good.
Okay, so then you have some, well, I'm doing a terrible job drawing, but this is why whiteboards are nice. You can erase and start over. So anyway, one thing that I was trying to look at was you want to make sure that someone's not just waving their arms wildly and you're counting jumping jacks. So you want to try and make sure they're somewhat aligned. And as with all these things, there are a bunch of advanced signal processing techniques you could do. What I did was basically tracked when someone went through a 0 crossing point. So let's just say here. And so the right wrist maybe crossed a little bit earlier, but I tracked for a few samples after that. And so I created kind of a window where they should cross at the same time. That was important because, well, I'll get into the difficulties of like when you lose points and stuff in a second, but that's important because you might not get all of the data points in the human pose estimation results. So you might get misaligned a little bit, or someone might just not have perfect form, and you get to choose in the app how much you're willing to tolerate there. So basically a count was when we 0 cross heading down on both arms within a short period of time. That counts as a jumping jack. And so when I started testing this, one of the things I noticed was that a lot of times when we were right near the center of the wave, so if we're looking at the arms, like when you're kind of at neck level, a lot of those points actually got missed because that's when your arms are moving the fastest. And so the frames from my camera were kind of blurry. Maybe with a better camera, you can adapt to that. But in my case, I was using this webcam. So so the problem was, and that's probably the most important time because that's when I'm actually tracking the 0 crossing. So I tried a few different really simple techniques. I started out by just zeroing out those points to see how it would work. And that's where I ran into the problem where it happened to be when they were actually crossing, when they were lost. And so I wouldn't see a cross at that time. I'd see it sit on 0. So what I ended up doing was just a really simple linear prediction using the last 2 previous points. And it only worked effectively to a point because if you're looking at, let's just put a bigger one here. So let's say we're like here, and we had a point at the top, and then we had a point here. The projection between these two could be like somewhere around here, right? So that might be fine, but then let's say on the other hand, you might have, if we come back over here, you might have a case where you have your points like here, and the next one, instead of matching the sine wave curve, you would actually get a point way up here, and that might mess up your later signals. If you get the next sample here, your next prediction, if you miss another one, would be way down here. You get kind of this weird situation. So it's not perfect. So one thing I did was kind of just factor it back a little bit so that it wasn't getting the full value that was predicted. And that was good enough for my example. You could use like a Kalman filter or something to smooth that out and actually capture the sine wave shape a little bit better. But I didn't feel like diving into that at this point. And so let's see if there's something else. So the other problem I ran into is that when you're doing jumping jacks, you're not really like standing at the same height all the time. You're kind of bouncing while you're doing it. And that was another case where it's kind of right near the center of the sine wave where you do a bounce. So if I can draw another wave, what I was kind of seeing was that it would look like this, and then you get a bounce, and then it would go up. and then it would come like this, and it'd bounce. And so you'd get all these extra zero crossings that were messing up my algorithm. So the simple solution there was to just average out the, do like a rolling average on the neck point. And that solved this issue pretty well. So yeah, I think that's kind of the diagramming part I wanted to go into. So now that we're getting a closer look at how this works on like an algorithmic side, I'll jump into the code. And yeah, feel free to jump in with questions too at any time. I don't need to just keep talking the whole time. So let me switch over to sharing my screen though. Oh, I don't have, can you allow me to share my screen, Komal?
Yeah, try now.
Awesome, that worked. Oh, there's a whiteboard thing on here that I don't use Zoom enough, I guess. But anyway, my drawing skills are better on paper than with a mouse. So probably appreciate having the drawing instead. So I'll take a quick look at the code here to kind of go through what I just discussed. So the main thing the main object here is this jumping jacks tracker. And I had bigger plans when I first made it because I wanted to track the legs and stuff too, like I described. But it ended up just tracking the wrists. So I have this single object to track the two wrists together and determine if the two wrists have crossed the zero crossing around the same time. And a few of the factors that you can use to tweak this algorithm are the center smooth samples, which is the length of the rolling average filter for the neck. And then the memory samples, which is just how long I'm checking to see if they cross together. So in this case, if there are the two arms need to cross within 4 samples. So that's kind of tweakable. The 4 is longer than I would have liked to put. I originally had 3, but there were some cases where due to the issues that I talked about earlier with the missing samples and the bad predictions, it was missing some cases. So in this simple example, I have a little larger window than I would have liked. And then the prediction factor was just what I was talking about, where instead of using the full linear prediction, I'm basically only using half of it. And so that kind of reduces the error in those cases where you go off in the wrong direction. And so each time we get a pose, I'm updating the wrist object. And then if that returns true, so every time, and we'll look at this in a second. So every time we do an update, it tells us if the wrists have both crossed this threshold of whether or not to count a jumping jack. And if that's the case, we increment our count, and then we clear the state or the memory in this case that was tracking whether the zero crossing occurred in each wrist. So let's jump into the wrist object. So I created, well, let's take a look. So I'll jump into that in a second. So for the center, I created this smooth value object, and it's just doing a rolling mean on these incoming neck samples. The left wrist and right wrist, I created these zero cross down values, which are just storing all of these values coming in from the poses and then determining if you cross the zero value. And it's taking in all of the inputs from the inputs to wrist. And so every time we get a new pose, and like I said, I'm only grabbing the Y values. We're just inputting those to these to the center, left wrist, and right wrist, and then checking if they have changed. And like I said before, there's that memory of 4 samples. So if they change within 4 samples of each other, then that returns true. So I wanted to jump up. This is really simple. The smooth value is just doing a mean over the last n samples and continuously doing that. And then I had to handle the case where there wasn't any values in there yet. And it's easy because that would be just the first try if something kind of went wrong. It's not a typical case. So I was just returning 0 in that case. It doesn't really impact and that's the default value here. It doesn't really impact the overall algorithm much. So the key part is just this rolling average, which is pretty simple. And there are probably fancier ways to do that in NumPy, but I just did it with lists. And then the 0 cross down value is a little bit more complicated, but not too much. So one thing to keep in mind is that when you get, let me jump over to the docs, actually, that could be helpful here. Yeah. So if we look at the pose estimation output, and actually one thing I should do is make this a little bit bigger so you guys can see it. It's probably too small. So one thing that's important to note, and let's see where we get into that. So this is the human pose result. We get our list of pose. So what happens, and it doesn't say it here, so it's probably an important thing for me to add, but what happens is that if the point is lost, it's a -1, which in the case of an image is fine because you don't expect negative values. It starts at 0, 0, and you can't really, unless you're mimicking going outside the bounds of the image, which the poses do not. The problem is that once you start doing some work with the signals and kind of zeroing them out and stuff, that -1 can really throw things off. So we have to do a special check to see if the -1 is present. And in that case, I'm calling get prediction. And that's just doing the like the linear prediction from the previous 2 points. And otherwise, we're taking the new value and taking the smooth value and subtracting what we got as input. And what that does is it centers the sine wave and it flips the sign so that it goes up when your arms go up and down when your arms go down, which was just easier for me to think about when I was working with it. So I did it like that. And I did a lot of, I'll probably jump in and show some plots of the data if you guys are interested in. So it helps analyzing that a little bit. Trying to think if there's anything else here, really. I think that's pretty much it. So you can see there's like a couple little tricks to consider here, but overall, I tried to use all really simple, basic techniques in making this work before jumping into anything more complicated, which I think if I have time, would love to do in the upcoming weeks or whenever I have time for that, to see if I can get some different filtering and more robust tracking of the jumping jacks. But let's just run this and then look at the actual output data. Because I mentioned in the webinar earlier, but didn't mention here yet, that I have a debug flag, which outputs all of these values to a CSV file. And that makes it really easy to just kind of either load it into another Python app if you want to, or I've just been loading it with a spreadsheet app and plotting it that way. Just it was easier to do that quickly. So let's go ahead and run that and grab the data back. Okay. So I'll just run it on my laptop. Well, yeah, I'll run it on my laptop. I think it will still get all of the jumping jacks. We will find out. Configure. I had this set up for the Xavier NX before, so switch it off. The thing I have to remember to do is run it with the video file. Not going to do any jumping jacks right now, sadly, unless there's strong demand.
I will vote for it to be live.
We'll do it with the video once, then I'll try. I haven't really done too much work on trying to see how I can screw it up either. I did some basic tests, but it'd be kind of funny to see how well it handles just kind of waving your arms around and stuff like that. So, okay, I'll try some stuff in a bit, but first, okay. Let me do, what did I do? Installed. Yeah, we'll run this and then we'll capture those samples because I want to look at what those samples look like. Start. And then debug. Cool. All right, let's see. This doesn't seem promising. Might be too much processing going on right now with Zoom, but we should hopefully, even if it doesn't show up in the streamer properly, it should still, the app should still function correctly on its own and output that debug file. So let's give it a minute here and see if it does kind of wrap up on its own. Otherwise, if I don't, you might be able to hear my fans going crazy right now with Zoom. So if that's the case, we'll just run it on the Xavier NX. That'll be easier. Yeah, it doesn't look like this is happening. Okay, so if we're going to run it over on the Xavier NX, I'm going to actually switch the model so we don't have to go through the compilation step each time. So if we do show, this will show we're using, as you know, the human pose model. If we jump over to the catalog, we have pre-converted versions of this model in TensorRT. So pose. So there we go. Let's take this one. And copy this. So now we'll actually have both models installed, which is fine in this case. We can use either one in the app then. So if we go back to the app, that's the name of it. Yeah. Configure it to run on the Xavier NX again. Install might take a minute to install the new model. I don't think it's that big of a file though, so should be okay. Looks like needed to refresh the Docker image too. And so what's going to happen is it's going to save that CSV file on the device actually in the application install directory. And so this will give me a chance to show you how to copy files back from the device and stuff like that. Because yeah, I think we have some little known commands to help you work on the device, and also just we get questions sometimes where it's like, oh, it saved an image, but I don't see it. It's on the device in the application directory. You have to manually grab that back yourself. So we did the install. Now we have the one I already typed out. We'll do that one. All right, here we go. There's some jumping jacks. Got all 10 of them. And
Eric, is it okay if we pause for a couple questions?
yeah, absolutely.
Okay, we have our first one is from AB, and he's asking, would a real sense have helped compared to a webcam?
Yeah, give me 1 second. Let me see if I can, I'll jump on the regular camera and also bring back my face.
Okay.
There we go. Yeah, I think it depends on what you're exactly trying to do. In this particular case, I'm not sure if a real sense would help so much, just because it's kind of like a flat motion, if that makes sense. If I'm facing the camera, that is. Maybe if I were standing at different angles might be helpful, but there are definitely workouts where the depth aspect would be really helpful. Something like, I don't know, if someone was doing like curls facing the camera, it might be hard to determine if they actually you know, what they were doing with their arm, because they kind of be blocking the rest of their arm and stuff like that. But the depth camera might give you a sense that, okay, their arm swung forward, and it would just give you a more complete idea of the shape of the motion in 3D space. So if you're trying to characterize between a bunch of different workouts, that could be really helpful, I think.
Okay. Actually, I think he wants to elaborate on his question a little bit.
Okay.
Hey, Evie, you should be able to talk now.
Hello, Eric. Nice webinar. Okay, congratulations.
Thank you.
Yeah. So my question was not related to depth. Okay. So my question was related to, so RealSense is a faster camera as well compared to getting the data acquisition perspective, because you mentioned in your, when you're doing the diagram, right?
Mm-hmm.
That the camera was also overwhelmed to get some of the frames, right? Because you used to lose some frames. So that was my question, whether RealSense camera not using the depth feature would have helped or not. So that was my question.
That's a really good point, actually. And I would love to try that.
So let me step in, Eric. AB, that's a great idea. I am debugging for another customer now. And what I have to do is I hard-coded the frame rate at 30 on our RealSense API. And I'm just realizing as I'm testing for another customer and things like that, I've done that. But you can go 30, 60, or 90 FPS on the RealSense. So, and I'm fixing that right now in our API, AB. So,
yeah, exactly. So that was my,
so I apologize if you use it. You've got frustration. So,
okay. Yeah. So yeah, that was my point. So I'm understanding that no depth was not a part of a role here.
Okay.
Well, yeah. Okay.
Yeah, that's it. And even at 30 FPS, just because it's capable of a faster frame rate, it still might have clearer images. It might be able to snap them quicker or something. I'm not super clear on the inner workings of it, but I was surprised when I was looking at the frames of the video that I captured that it's pretty blurry, especially in the middle of the jumping jacks motion where it was having trouble detecting my wrist. And I don't blame it, because I'm mostly a blur in those frames. So it's surprising that it got anything around there. So yeah, I would love to try some different cameras and see what different kind of images I get from that. And RealSense is definitely a good one to try, just because it has that crazy fast frame rate. So
yeah, that's it. Thank you.
Thanks.
Okay, and then the next question is from Donald Childs. Donald, would you like to ask your question? He just raised his hand.
Okay.
Donald, you have permission now on Zoom to speak. Okay, let's move on, and then maybe when he's ready, he can ask.
Okay.
Yeah.
Any other questions, or should I jump back in?
I think we're good to go.
Okay.
Yeah.
Cool. I will share my screen again. All right, so we just ran the app, right? And I was a little surprised, I guess. I was seeing about 15 frames per second before. We're about 12 right now. That should still be plenty fast, but we'll get a better idea when we look at the samples. We'll understand what, if any, problems would arise from getting fewer samples. But it still counted all the jumping jacks just fine, so I think we're okay. So one thing you can do if you want to understand if a file was saved onto your device directory is you can use, let's list out all the commands. We have two commands that are helpful here. We have the AI app shell, which lets you open up a shell in the app's device directory, and I believe it loads the Python virtual environment and everything. So that's pretty nifty if you want to go and manually tweak things on the application side. And also we have the AI app exec command, which lets you just run a command and it brings the feedback in the terminal here. So let's see what we have going on. There's probably a bunch of saved files. Oops, I didn't write a command. Probably a bunch of saved files over there because I've been running a bunch of stuff. So yeah, whole bunch of samples. Let's see, this is probably the one that's relevant. So well, let's just copy all, we'll just make it easy, copy all CSV files back. So you can use SCP I'm not sure about on Windows, but definitely on Linux and Mac, I believe you can use SCP, which is secure copy over SSH. And so I have the SSH connection set up for this, which is alwaysAI at Xavier X test 0. And then you just put in the path, which is the default installation path was alwaysAI / jumping jacks counter. And then we're just going to do this CSV and then a dot for the current directory here. And we got all those files back. So now I can take this one and yeah, let's take a look at that. Oops, where did it go? So here we have, I captured the raw values for the wrists and then the neck. And then I also captured the centered values and then the smooth value for the center. So let's first take a look at what the, let's take a look at the raw values first. So we had, yeah, and then center raw. So this will be the two wrists and the center, just how their Y values track together, just to kind of give a visual to what I was trying to explain earlier. So let's make this a lot bigger. So this is the stage in which my arms are just down and I'm standing still. And then what you can see is that in the red is the right and blue is the left. So especially with the left arm, you can see that all of these -1s are points at which it couldn't get a detection for that. And so those are, you can see that there's actually quite a few where we have to do some sort of prediction. And that could be mitigated potentially by the camera, but in this case with my system, this is what I was kind of facing. And so, and each of these dips is actually a peak in my arms. So one thing that you can see is that the neck was also kind of doing a mini peak where exactly where the arms would kind of be crossing that threshold. So that resulted in kind of that weird jump that I was talking about, right where the zero crossing was happening, that made it really difficult. And so if we jump back, and I guess I can show the smooth value isn't that interesting. We all know what an average looks like, but then we can do the left and right arms. So this was after the centering, so removing the kind of the DC bias signal, and then also doing some predictions. And it's kind of funny to see where the predictions happened. Like in this case, so once again, the right arm, it does a pretty good job of following that along, and you can see the zero crossings are pretty distinct. We can also see that the neck wasn't really in the center of the wave. It's actually closer near the top. And so other techniques would do a better job of getting that center actually in the center of the waves. We can see here, this was a good series where the detections were missed. And we can see that had I not done that factor of 0.5, this would have just kept going up and up and up. And I'm not sure if it would have had a strong impact here just because of the way that it's placed. It could have, if we missed that many samples here, for example, and it looks like we did miss a couple here potentially, but it would have, pushed it off way more in a worse direction. But here it kind of rounds off because I had that factor of 0.5 multiplying it, so it doesn't go off too far. And in this case, we can even see that if we look at this point here, will be crossed, it's not until 2 points later that we actually determined that the left arm crossed as well. So a window any shorter than 2 would have, I think we probably need, no, two would have done it, I think. So if we did less than 2, we would have missed this sample, or probably less than 3. Either way, and we have similar issues in a couple other places too. So yeah, we can see here where we had a few predictions, and so yeah, it's interesting though. Actually, in this run, a lot of the missed predictions. Well, so if you think about it, these points would have potentially crossed over, and instead we're predicting them to be kind of shorter and not actually crossing over, which is impacting our predictions quite a bit. So this falls back into something like using something like a Kalman filter or something that would actually track the sinusoid shape would be much more effective than what I've done. But this was kind of a simple enough solution that got it working. So let me see if there's anything else interesting here. I think pretty much covered a lot of it. I think we see a couple cases like this where it kind of dips down and then jumps back up. And then it almost looks like it's possible that this was a missed point. And this is one of those where it starts going in the wrong direction because somehow we had this weird misdetection. And so if we use these 2 points, we think that we're ascending instead of descending, and the next prediction is up instead of it actually crossing like it should have. So just some interesting cases to dig into. I think that's everything that I wanted to cover here. So we can try running this thing live a little bit and see how that works out. We don't have to reinstall or anything. We can just run it without a video file. And then I think I have to set the camera index to 1. Oops, gotta spell it right though. And we'll save the output for this too. So let's see how this works. I might have to align the camera a little bit. Okay, there I am. So I'm just sitting in my chair right now, but and I'm way too close. Okay, I have to get up and do this then. But anyway, so hypothetical jumping jack, I'm not even, if you just do that, if you just do like one arm, it's going to work correctly to not get that. If you just, I don't know, just wildly wave your arms, you're going to break the algorithm a little bit just because we're not measuring like amplitude of the wave at all, which I think would be a really important thing to check actually if you're trying to make this a lot more robust. So you could do something like determine the distance that the hands moved in the Y direction compared to like how tall the person is or something, just to see if they actually move their arm more than just doing short little things like this, because just racking up jumping jacks. But yeah, I think, I mean, I'll probably actually spend some time looking at that data to see what it looks like. But I don't know, is there anything else people want to see with it?
We actually have 2 participants who raised their hand.
Okay.
But before we take their questions, I just want to say good job on getting your exercise for the day. Okay.
Yeah, I'm not sure if that burned enough calories. I think I need to get in and do some more after this.
Yeah. Oh, thanks. It takes a really great courage to do that on live in the jumping jack. Like, yeah. So, okay. This brings me a very interesting thing as well. I like the way you have the test cases as well. It's really there's a good reflection on that. The question what I had was, how if you had, would you have been to doing this tackle this problem differently as well? How about if we had recorded, say, multiple people doing jumping jacks, like one at a time, like getting all this, and trying to train a model that telling the model that this is jumping jacks, and then we are doing something else that is not jumping jacks.
Yeah.
Based on that. So would you think that would have been an easier approach or will that be more accurate approach? Because getting all this multiple factors, handling the heights of the people, the different styles of jumping jacks, all this kind of stuff. So because I had posted a question in Discord as well related to pose estimation, okay, to just based on Lila's webinar as well, okay.
Yeah.
So everybody has a different silo. So I was trying to detect, say, simplest ways, okay, to detect person who is sitting, who is standing, okay. Everybody has a different styles of sitting. So like a man would sit straight, a lady will have sit cross-legged, or any person will sit on the sideways. So how we all handle these counter cases using human pose estimation model, because you have to because that is based on points, right? Your joints. So joints can be like when different styles, when joints are all over the place. So how do we do that and make that but rather than if you give so many pictures and of people sitting in different kind of ways, then it is easier to train. Or that is, I want your opinion on that, because I'm not very expert in that, not at all.
Yeah, and so I think it's a really good question. It's something we've kind of talked about internally, but just due to resource constraints and stuff, it's not something that we've looked into at this time. Just we have a ton of stuff coming in to work on all the time, and so, but the idea that you could train a model on the output of this on this human pose data is really interesting, and I think if you're looking to make something that can work generally across a lot of different people, a lot of different use cases, that would really be a really good way to go. And the neat thing is that it kind of goes from a computer vision problem to a data processing problem once you get these data points back, right? So if you can normalize these data points on something like, I don't know, just kind of choosing the center of the body and getting all of the points based on that, input that into like an SVM or something to train it, you could definitely get some get a model that would understand these different things like sitting, standing, different workouts. I think when it comes to maybe positions and actual action recognition, you'd probably need a lot more data to understand an action, and it'd be a little bit harder to train probably, but certainly like something like sitting, I can imagine would be pretty straightforward actually to train something like that. So yeah, I think that's, I haven't tried it myself. I mean, I've done other model training on like non-computer vision model training on similar things, but I haven't tried it myself with the output of human pose and stuff. And it's definitely something that I want to try at some point.
To be honest, I've trained only like two models in my so far. That's so I'm not a model trainer. I'm more like a user of the models. Like, but model training is really interesting. Like if you have the right data set, and if you know what you're doing, then definitely you can excel in that. But sometimes it's really difficult for a person who does not have a background about data science.
Yeah,
it's very, very difficult.
So Eric, my talks with Andreas and the person that actually did pose estimation, a lot of work is not here in the expert. So maybe if we're struggling a little bit, it's because we work with it and play with it like what Eric's showing you, but the expert really on our team is Andreas. And what he was saying is going to the higher levels, what he would do is use pose estimation, but then use some type of support vector machine to try to capture where, it's more of a clustering type of algorithm, as you said, into data science, say these are different sittings and, and do that. So like what you're saying with the difference between a man and woman, different types of body shape, things like that. And support vector machine is really about, binarily clustering. So sit there and see a pose estimation, and then it will determine does it cluster into that sitting position and so forth. That's how he explained it to me. I have not done it, but that's what he was thinking as he goes up into higher level algorithms on this. But sorry, I'll turn back.
I think that's the beauty about multidisciplinary teams, like which complement each other, and that's how we can deliver best solutions.
Thanks, Xavier. Okay, I want to give Donald Childs a chance. Donald, are you there?
Yes, I am.
Oh, hi.
Hi.
Yeah, did you have a question for Eric or
Yes, I
Steve?
did. So I've been working on my own individual version for a while for this AI, and I wanted to be able to start making some sales models of it. And I was just wondering, when are we able to do this type of thing?
To do some what? Sorry.
Make some models for consumers.
So I think Steve can probably jump in on this, but we do have a retraining tool. So if for example, someone wants a model that does something very specific, you can take one of the pre-trained models that we have and benefit off of the training that's already been done using transfer learning with a new data set and kind of retrain that model to fit your new classes and stuff. And then that model is private to you. You can use it however you like. And I think that kind of fits your use case. And I think that's, as far as I know, it's available right now, right, Steve? It's out there.
Yeah, that piece of it. But if Donald's talking about later on a store type function and so forth, we talked about it. It's always the security of key. How do we secure your algorithm? And we haven't figured that out yet.
Mm-hmm.
Okay.
On that piece, because that gets to be a difficult question on edge devices, right? So remember, our inferencing is going off the cloud. So once you start to do that, how do we lock it down? So we have some ideas that we're thinking about from this quarter, putting up we want to put in so we have a published runtime. So you have a runtime conditions, and that will go up into a private Docker registry is what we want to do. Because right now you're in development, your application sits in a virtual machine, and then all of our all the AI, alwaysAI libraries and middleware and so forth is in a container, and they're talking through that, and that's how you're able to iterate so fast. But hopefully we're going to go to a build, and then I guess my point is once there, then if somebody has to publish up in there, it allows us to have the control system to distribute that algorithm. So hopefully, if it works out, and again, we're talking about that, building this out for this quarter, that we'll start to do that, Donald, around first quarter, but definitely we can assist you and so forth. And at least, if you have a model, tell us, and we will talk to our people that want to use it and have ideas that come in and want a model. We can point them towards you as somebody who can provide that model to them.
Okay, that sounds great.
Yeah, on that. And by the way, Sache Malik, we all know from OpenCV, he's got a modeling team too, and so forth. So, but any of those types of things. But Donald, that's our goal, is to ultimately give you a store position on that. So it's just securing your intellectual property. We want to make sure we do.
Okay, that sounds great. Yeah, that's all that I had to ask then.
Yeah, and David Tischler has also added that, to Steve's point, IoT devices cannot have assumed security, so they can be stolen, removed, or reverse engineered. And then he said, as opposed to a server in a data center where it's inherently assumed secure. We can talk about that, David. I have other ideas about that, so maybe we can discuss that offline. Okay, this is a question from David W. Do any of the current alwaysAI models use reinforcement learning?
Right now, no, but I think you can absolutely bring in other libraries that do reinforcement learning and stuff. I'm not sure exactly how you would fit the pieces together, but if there's something specific that you want to do, you can bring it up on Discord, and then we can kind of work through it and see. Just make sure there aren't any obstacles in your way. But typically we try and make it so that if there's something out there in a Python library you want to use, you can bring it in and use it. So that's our goal. Let us know if you run into issues with it, and we'll work through it and make any fixes on our end.
Okay, thanks. All right, do we have any other questions? You can raise your hand, type them out. Okay, Sorry, Eric. While everyone's kind of writing out their questions, what I'm going to do is I'm going to share the results of the poll. I'm going to end this and share the results. So okay, if you can see this, it's really interesting. I think you won't be that interested to see what everyone's been working on or like where you heard about Hacky Hour from, but I think the most interesting question was, what's your favorite TV show about tech? And it seems that there's a tie between The Big Bang Theory and Mr. Robot. And my opinion, just my opinion, I feel like Big Bang Theory is not really a tech show. It's more of a science show, but I'm glad it's in the top results. Okay, does anyone else have any questions? Okay, we have a question from Juan. Juan, I gave you permission to speak now.
Yeah, hi. I guess I have talked with Steve in the past, a long time ago at UCSD, but my question is, I'm working on autonomous vehicles, well, kind of. So here, when we do the deployment and in the Jetson, I just was actually running everything, and I had already played with like alwaysAI like 8 months ago, but finally I moved to a position where I could use it to do actual things. So my question is, if I deploy it in the Jetson as a standalone, application that will give me just, let's say, the centroids, will it stay running there without like having to need any connection with the desktop I connected from? Basically, like, can it run by itself indefinitely, let's say, like a piece of software?
Thanks. That's a great question. So one thing, and maybe I can share my screen really quick for this. Just a second. So we've let me head over to the documentation. So one thing, and so you're kind of referring to what we talk about as development mode. When you're working on your app, you kind of have this one-to-one connection over SSH with the app while it's running, right? And you need to maintain that connection or the app stops. So one thing you can do right now is package your app as a Docker image to be run as kind of a standalone app. And so the instructions are here in the documentation in the packaging an app as a Docker image. And it's really simple now. This is fairly new-ish feature. After you do the app install, you can do the app package command with an image name. And then from there, you just SSH over to the device or use the app shell command, and you can do a detached run of your application. And what that means is that when the Docker image starts up, it's not going to be printing all the logs and stuff in the foreground. It's just going to be running in the background, and you can use the Docker commands to start and stop it. So once it's up, yeah. Sorry?
I see. Perfect. No, I was like, oh, I see. That didn't exist back then. That's why I was curious about it.
Mm-hmm.
Perfect.
Yeah, so this should solve your problems. Then your autonomous device can go off, do its own thing. It's probably, depending on how you want to build it, you might want to capture the logs in a text file or something so you can easily check them, or have some sort of a ping to a server or something just to let you know it's alive. But yeah, all sorts of cool things you can do when you get to that point.
Yeah, I guess, then in that case, since it's Docker, I just consume it as a, HTTP connection, kind of like a little server, and just have a little API that is my own app.
Exactly.
Okay. Perfect. Thank you.
Thanks.
I was on mute. All right, thanks, Juan. Any other questions before we end Hacky Hour? Let's see. Okay, AB's provided some references to Docker. So Juan, I think you could take a look at that if that's helpful.
Perfect.
And if there's no other questions, I think we're ready to call it a day. Eric, thanks so much. As always, great demo and great work on the NVIDIA webinar. Just wanted to publicly say that was really great. And thanks for doing a jumping jack for us live. And yeah, we do this every Thursday from 2 p.m. to 3 p.m. So join us next week. We're working with a couple of people a couple of developers who might come and showcase what they're working on. So stay tuned for that. Next week, September 30th, we're hosting a webinar with iCloud, and we're going to be addressing some of the challenges associated with deploying computer vision on the edge. With that, I just want to say thanks again for joining, and thanks for being a part of the community, and we'll see you next week. Bye, everyone.